Section 6.1, angle measure, degrees, and radians, and we'll also look at grads. The objectives for this section are that you know the basic parts of the circle, including radius, angle measure, and arc length, that you know what it means for an angle to be measured in, and let's change that real quick, there we go, radians, degrees, and grads, and be able to convert from degrees to radians and vice versa. Alright, first thing first, we have a circle. In our circle, we're going to label the radius, the angle measure, arc length, and sector area. If you already know these parts, you can try to work this out on your own first. If not, you can watch along and hopefully learn where these parts are. Our radius is the distance from the center to any point on the circle. So both AB and AC are our radius, R. Angle measure is this openness that's created with the two radii. So what I've marked here with this arc is an angle measure theta. For angle measure, we like to use Greek letters. We typically default to theta, especially if we're only looking at one angle. If we're looking at multiple angles, we might use other Greek letters such as alpha, beta, gamma, and so on. Arc length is the portion of the circle's circumference that is subtended by the angle. That's our arc length S. And lastly, we have sector area. Sector area is the portion of the circle's area that is cut off by this angle. Thus, we have the four main parts that we need to know: radius, angle measure, arc length, which is the portion of the circumference that's cut off by this angle, and sector area, which is the portion of the circle's area which is cut off by the angle. Do know that for circles in general, we start in the 3 o'clock position and we move counterclockwise. This is how we understand to be positive motion around the circle, and we do default to that 3 o'clock starting position. Okay, we're going to look at what it means to have an angle measure in radians. Angle measure can either be in degrees or radians. I'm guessing most of you already have an understanding of degrees, so I want to look more closely at radians. If you have a piece of string, you can do this activity with me. I want you to cut off a piece of string. It can be any length you want. You're going to use that length of string and make that string the radius of a circle that you'll then draw. That's the best circle I can get for you. We have radius R, and if you want to, you can write that down to the side what your radius is. The first question is, how many times does your piece of string fit around the circumference of your circle? Alright, we have our piece of string, which is our radius. We're going to pick it up and we're going to lay it across the circle. So we can have 1, 2, 3, 4, 5, 6, and a little bit. This string, our radius, is going to fit around a circle about 6.3 times. We have about 6.3 radius lengths on our circle. So if we were to cut our circle here and stretch out the circumference, it would be equal to 6.3 of